day. My name is Flanan Sikopo. In today's topic of mathematical requirement, we are going to look at the subject itself, physical science. Let us quickly look at the objectives. At the end of this lesson, learners are expected to add, subtract, multiply, and divide. Let us quickly look at the main lesson, division. So I'll quickly use the four main operations to give us a bit of an understanding, because mathematical forms a prerequisite for any chemistry or physics content. Hence, we need to acquaint ourselves to the mathematical requirements so that at the end of the lesson, we are going to incorporate mathematics and the concepts in physics to be able to perform some calculations. So I'll use the basic concepts of addition. So if we look at addition, for example, suppose we are given two variables that are supposed to be added. Because you realize that in physics, when we talk of motion, or if we, let me say we start with forces. A good example is that you might have two forces that are moving in the same direction. So therefore, it means addition is going to be paramount in the sense that if I have x plus x, this will give us 2x. But how does this relate to the physics concepts? It means you might be provided in a situation where you have two forces that are moving in the same direction. So in other words, a force is exerted on an object. Equally, you find that you might have a pushing and a pulling force. Therefore, if you regard a force of 20 Newton to be the one which is exerted on an object of interest, plus another force which is regarded as a pulling force. Suppose you were to put a force at the end of an object which is pulling, and then equally you also exert a force at the beginning, which will act as a pushing force. So if we assign it a value of 30 Newton, this will translate to the total force of 50 Newton. So by implication, this means we need to understand that we can only add like terms. If we use the same example, of course, it will also be able to, it will make our life easier in a sense that we can also change the scenario to say, if we were to give a very simple example of a brick, quite common, such that this brick you exert a force of 20 Newton on the left side, and then on the right side you exert a force of, say, 30 Newton. You realize that these two forces are rather different, hence they will provide us with a resultant force which is going to be different to the one that we have added earlier. Remember, we said 20 Newton plus 30 Newton will give us 50 Newton. This is now when we are adding two forces that are in the same line. However, if two forces are opposing each other, this does not form the addition part of forces. Therefore, it will give us another concept on subtraction. This forms part of subtraction. Because for subtraction, it means we need to consider the first force, which is A, the second force, which is B. Therefore, we can say 30 Newton minus 20 Newton. This will give us the difference of 10 Newton, which is regarded as the resultant force. So that's why I stated earlier that when we are talking about addition, subtraction, multiplication, division, those are necessary requirements that must be understood before you venture into the subject itself, to go into the main content. Now we can already see from this example that if we are talking about addition, it means we need to consider what we call like terms. For addition, we gave the first example of x plus x to give us 2x, whereby in a situation where you have two forces that are in the same line, you can have 20 Newton plus 30 Newton to give you 50 Newton. So basically it means it can only be added if you have like terms. However, if we have subtraction, this translates to say you have a force of 30 Newton in one direction, a force of 20 Newton in the other direction. So the 30 minus 20 will give us the 10 Newton. So that 10 Newton, which acts as a resultant force, allows us to see the difference between those two forces that are applied on the same object. And then we can also extend this to multiplication, because when one talks about multiplication, you realize that for multiplication, using basic concepts, if I have a over b multiplied by x over y, this will result in us multiplying the numerators, where we have a multiplied by x to give us ax, and then the denominators b multiplied by y to give us by. So ax over by, which acts as a product of those variables of interest, a, b, x, and y, will give us the main product of that equation. But why using multiplication? Again, I must be specific that there are cases where we might have a formula. Say a very good example, if we use the formula of gravitational field, the weight, to be more specific, if I have weight equals to m multiplied by g, the mass multiplied by the gravitational field, you realize that for you to be able to generate that product for w, which is given by mg, it means we must specify the value of m, and then we must also specify the value of g, so that those numericals, once they are multiplied, we'll be able to generate what we call a product as a result of m and g. Therefore, if we have an object which is having a mass of 20 kilogram and the gravitational field which is set at 10 Newton per kilogram, this translates to the weight of 200 Newton. Therefore, that 200 Newton in that case acts as the product of those two. Now, multiplication in essence plays a fundamental role for you to be able to come up with products within any calculation. This is a bit more distinct because I confined it to w equals to mg. But you may also have those cases where you can have four variables as provided in the formula, where you have a over b multiplied by x over y. Later on, when we look at the equation, the reciprocal equation, say for example, if we talk about the inverse proportion, you realize that there are those cases where you might have a spring that will stretch according to the amount of weight which is provided, or the mass which is provided to that very spring. In other words, we can say the force is exerted on that spring based on the mass which is attached to the spring. So hence, in as much as you put more weight or more mass on that specific spring, it means it will provide you with the stretching. So that can also give us a better analysis on how we may be able to multiply so that we generate proper results. Alright, still on the mathematical requirement, we are still looking at the concept of multiplication. Because say for example, if we have y equals to ax. Now, this is regarded as a direct proportion. For example, if y increases, x is also going to increase. I'll give a very simple example on how we may form graphs that will give us a direct and an indirect proportion. Say for example, if we have a graph regarded as the one for direct proportion, and then another graph which is regarded as the one for indirect proportion. Here we realize that if we consider we have y on the y-axis and then the x on the x-axis, these two or translate to a direct proportion. So if I have y and x, this will translate to an indirect proportion. Therefore, the equation y equals to a over x will be equivalent to this graph type, and then y equals to ax, this will be equivalent to that graph. So yes, we have so much to do in terms of multiplying, because as I've indicated, y equals to ax. First, the value of a, that limit of proportionality, must be established for you to have a link between y and x. And then equal, of course, no, in the second situation where you have the inverse proportion, the value of a must be worked out, which acts as the limit of proportionality. And then in this case, you will still be compelled, especially in the first equation, where you will still be required to multiply a and x so that you can determine how much y is going to increment. So these are just basic concepts on mathematical requirement. I'll move on to a new part to explain more on division. And so we are going to look at the division. From grade 8, 9, 10, these are regarded as basic concepts. Once again, I'll use the variables a over b divided by x over y. So this will give us the quotient. If I have a over b, so this will, we take the reciprocal of x over y, so this will give us y over x, and then from there we apply the same application that we did for multiplication. So here we multiply a by y to give us a over y, sorry ay, and then b multiplied by x to have b over x. So in simple terms, we need to remember that whenever we are dividing, here we have one term. This is regarded as one term because a term, remember, is separated by plus or minus. So therefore, if I have a over b divided by x over y, so this is regarded as one term. Therefore, the first part of this term, a over b, does not change. So what is going to change is the x over y. So it means if I have a over b divided by x over y, the y goes on top, the x goes down. So in this case, y was a denominator, it will be taken up as a numerator. X was a numerator, it will be taken down as a denominator. Hence, from there we can have a over b multiplied by x over y. So this is how we can get the final quotient, ay over bx is the result. Because basically we are changing from division, because when you divide, the answer that you generate is a quotient, but then that quotient is going to be retranslated into a product, because we have four variables, a over b, y over x, and then finally you say ay divided by bx to give you ay over bx. This is all about division, but someone might pose a simple question again. Why division in physics? There are so many cases where we may apply the division, because if we use the equation, say for example F equals to ma, this is a situation where maybe you are provided with the force, you are also provided with the mass, and then you want to find out the amount of acceleration which is available for that specific object, because a force is exerted on an object, and then having a specified mass, you want to find out the rate at which this object is going to move. So therefore you need to make A the subject of the formula. So you have A equals to F divided by M. So therefore, if I have F over M, that in itself is classified as division. So that's why it is again necessary that we need to acquaint ourselves to the concept of division, because it allows us to connect the variables of interest such that we may be able to find A, in that case, if we divide F over M. Alright, just a quick summary on what we have done. We were looking at addition, multiplication, subtraction, and division. So the four terms, addition, multiplication, subtraction, and division, are quite useful in mathematics because they form as the basis of the subject physics. Because you might say you don't need mathematics within a physics topic, but they are supposed to be worked out concurrently, because without mathematics you can't do physics. So that's why I went on first to give you an analysis on how we may be able to apply addition, multiplication, subtraction, and division. So I started by looking at addition, where I gave a very simple example where you have two terms, x and x, to give us 2x, and then you can already see that in this case, if I have 2x acts as the sum of those two variables, x and y. So I also gave an example where I have 20 Newton plus 30 Newton to give us 50 Newton. Then this was for addition, and then the subtraction part, I just gave a simple brick where two forces are opposing, where you find that the resultant gave us 10 Newton, 30 minus 20. And then the third last, the multiplication part. When you have multiplication, you can rely on the concept of multiplying the numerator multiplied by the numerator, denominator over the denominator, whereby I gave a simple case where, for example, if we look at the direct proportion, this was part of the previous part, the multiplication, where I said y equals to ax, the equation that connects y, a, and x, where if it's a direct proportion, you realize that x and y are directly proportional. And then in this second example, the variable y is not directly proportional to the variable x, for the mere sense that y increases and then x decreases. And then lastly, we looked at the division, where I gave an example of variables a, b, x, y, whereby if we divide ab over xy, ab does not change, so we change the variables x and y. Y goes on top, x goes down. From then we do multiplication, where we multiply ay over bx, and then from there our final product is ay over bx. So basically, this concept connects us to what we call the equation of, we may be in a position to connect the force, the mass, and the acceleration in such a way that if I'm provided with the force and the mass, I'll be in a position to calculate the acceleration by having a equals to f divided by m. This part concludes the last part of what we were doing. We had addition, subtraction, multiplication, and division. So therefore, this is part of mathematical requirement, which means we need mathematics in our physics lessons, so that we incorporate mathematics and physics to be able to perform calculations. Without mathematics, as I've indicated, it's quite difficult. Until next time, thank you for watching.